Alright, in our next unit, which is a smaller unit, we're going to be talking about inverse functions. And so again, an inverse is when you flip the x and y coordinates. And so let f be a differentiable function if f possesses an inverse function, and we notate that by f to the -1, that means inverse, it doesn't mean derivative, such that f of x is equal to y, and then the inverse is f of y is equal to x. So the inverse gives you the x coordinate where the parent function gives you the y coordinate. Then the inverse is differentiable for any x for which the derivative of your inverse function is not equal to 0. Okay, so you don't want a 0 for your x coordinate. And the way that we do that is the derivative of your inverse. I know that looks like crazy notation, but in simple terms is 1 over the derivative of your parent function. And so let's kind of talk about some steps. Step 1, first find both your x and y values for f of x, which is your a and your b. If you're only given b, you want to set b equal to your parent function. So if you've been given your y value, you have to set it equal to your function and solve for x, which will be your a. Find your derivative, plug in a, and so the derivative of your inverse at your y coordinate is equal to 1 over the derivative of your m. So let's look at several examples. Number 1, if g is the inverse function of f and f of 3 is equal to 2, find the value of g prime of 2 for f of x is equal to x to the third divided by 4 plus x minus 1. And so when we're talking about an inverse, the point for f is 3, 2. That's our f. If we're talking about g will be the inverse of that, so we're switching those x and y coordinates. And so the y coordinate now becomes the x coordinate for my inverse. Remember, we're switching x and y. That's what inverse means. And so g of 2 is equal to 3. Okay. So the way that we find g prime of 2 is we need to take our derivative. So let's take the derivative of f of x. And so that will give me 3x squared divided by 4 plus 1. And I'm going to plug in my x coordinate for f. And so my x coordinate for f is 3. So f prime of 3 is equal to 3 times 3 squared divided by 4 plus 1. Well, that will be 27 over 4. And I'm going to do, instead of 1, I'm going to do 4 over 4. Well, that's equal to 31 over 4. Well, according to my rule, the derivative of my inverse, so g prime of x, is equal to 1 over f of x, or if you want to think about it, it's similar to your normal, except for we're not talking about the negative version, we're just doing 1 over our m. So please don't get this confused with the normal line where you're doing the opposite reciprocal. In this case, when we talk about inverse, we're just doing 1 over m, not the negative version, just 1 over m. And so this right here is my m, and so I'm going to, my g prime of 2 is going to be 1 over 34, or excuse me, 31 over 4. So that means g prime of 2 is just the reciprocal, 4 over 31. Number 2, let f be the function defined by f of x is equal to x to the 5th plus 2x minus 1. If g of x is the inverse of f and the point 2, 1 is on f, what is the value of g prime of 1? Again, g is going to be flipping that, his point is going to be 1, 2. Remember, I'm going to be flipping the x and y coordinates. So let's go ahead and take our derivative. So f prime of x is equal to 5x to the 4th plus 2. And I'm going to plug in the x coordinate. This is f. Here's my x coordinate, or my point for f, my x-coordinate in this case is 2. So 5 of 2 to the 4th plus 2. This is 5 times 16 plus 2, which is 0, carry 3, 80. Plus 2, 82. And again, remember this means it's my m. And when we're talking about the inverse, so the inverse is going to be g prime of 1. Remember that 1 is the y-coordinate for my f of x. So g prime of 1 is equal to 1 over f prime of 2. While f prime of 2 is 82. So we'll do 1 over 82. Number 3, we're going to be using our calculator. If f of x is equal to 2x plus cosine x, find the inverse function of f of 1. So again, when we're talking about the x and y coordinates, if we're talking about the inverse of f being 1, that means I have some sort of x, comma, 1. So I need to figure out what is my x so I can plug that into my derivative. And so I'm going to use the calculator to help me out. So I'm going to go ahead and plug in my function f 2x plus cosine x. And we want to know where is the y-coordinate, what is x when y is 1. Oops, lost my calculator. And so I'm going to go ahead, I'm going to just do the intersection. So here I'm just going to do y is equal to 1. And so I'm going to find the x-coordinate that's the intersection of these two functions. So let's go ahead, I'm going to do zoom 6 to make sure my function is not too crazy. And I'm going to do second trace, so I can get to calculate. We're going to go down to 5 for intersection. First curve, hit enter. Second curve, hit enter. Does it want me to guess? Sure, why not? And it gives me the intersection at x is equal to 0. So I know what x is supposed to be. X is supposed to be 0. So it gave me this y of 1. My 1 is still highlighted, and so my intersection, my x-coordinate that I want, is going to be 0. So we're going to go to second quit. We're going to go to math 8. And we're going to plug in our function, 2x plus cosine x. If you wanted to, you could have stored this into y1 and plug in y1. This is just another way of doing it. So next comes our independent variable, comma x, and then comma the x value we're evaluating at, which is 0. And let's hit enter. And so right now this is the derivative of f prime of 0. Well, I want the inverse of that, so it's going to be 1 over what my m is. This is my m is 2. And so we're going to write, since we've been looking for my x-coordinate, we found that out that x has to be 0. And we found that f prime of 0 is equal to 2. The inverse, the derivative of my inverse, is going to be 1 over f prime of 0, which is 1 over 2.